Same search problem, two different approaches. One checks every item 1,000 steps.
The other uses binary search, 7 steps. Same result, 1,000 times faster.
That difference has a name, Big O notation. I am Mahaz, episode 58.
Data structures and algorithms from zero in Python.
This is the episode that gets you hired. Data structures are ways of organizing data in memory. Algorithms are steps your code follows to process that data. Together they answer one question. Is your code fast enough? A list of 1,000 items. Find one specific item. Do you check every item one by one? That is 1,000 checks.
Or do you use the right algorithm? That is 7 checks.
DSA is the difference between code that scales and code that crashes. Big O notation measures how slow your code gets as data grows. O of 1 constant time. No matter how much data, same speed. Example, reading the first item in a list. O of n linear time. Double the data, double the time. Example, a loop that checks every item once. O of n squared quadratic. Double the data for time slower. Example, a loop inside a loop bubble sort. O of log n logarithmic. Double the data, only one extra step. Example, binary search. The best possible for searching.
A stack is last in, first out.
Think of a stack of plates. You add to the top, remove from the top.
In Python, a list with append and pop is a stack.
Append adds to the top. Pop removes from the top. Real uses. Undo and redo in any text editor. The call stack, how Python tracks which function called which. Browser back button, each page pushed onto a stack. Queue is first in, first out. Think of a queue at a shop. First person to arrive, first to be served. In Python, use collections.deque for a proper queue. Append adds to the back. Pop left removes from the front. Do not use a regular list pop of 0. It is O of n very slow. Deque pop left is O of 1 instant no matter the queue length. Real uses. Print queues, WhatsApp message delivery, OS task scheduling. A linked list is a chain of nodes. Each node stores two things, the value and a pointer to the next node. There is no index. To reach item 5, you walk from item 1. Inserting at the start is O of 1. Just update the pointer. But searching is O of n, you must walk the whole chain. Python does not have a built-in linked list class. You build one yourself using a simple node class. This is exactly what an interview will ask you to do. 30 seconds before binary search and sorting. These two are the most common interview questions. 58 episodes. Free. Every day. If this series is helping you, 1 subscribe is all it takes. 13 bonus episodes still ahead. Tap it now. Okay, binary search. Binary search. The algorithm interviewers love to ask about. Requirement. The list must be sorted first. Step 1, check the middle item. If it equals the target, you are done. If the target is smaller, search only the left half. If the target is larger, search only the right half. Repeat. Each step eliminates half the remaining items. 1,000 items, at most 10 steps to find anything. That is O of log n. The best possible search algorithm. 2 sorting approaches. Very different Big O. Bubble sort. Compare adjacent pairs. Swap if out of order. Repeat until no swaps happen. Simple to understand. But the Big O is O of n squared. Very slow for large data. Python's built-in sorted function uses timsort. Timsort is O of n log n. Dramatically faster. For 1 million items, bubble sort takes 1 trillion operations. Timsort takes 20 million. Same result, 50 times faster. Always use sorted or dot sort in real code. Never bubble sort. Your challenge. Step 1, implement a stack class with push, pop, and peek methods. Step 2, implement a queue using collections.deque. Step 3, implement binary search from scratch, no imports. Test each one. Print the results. Bonus, measure the time difference between linear search and binary search. Use the time module. Print how many seconds each one took. Reply with a screenshot of your output.
I check every single comment.
Let us recap what you learned today.
Big O, the language for measuring algorithm speed.
Stack, last in first out. Pend and pop.
Q, first in first out. Deke with pop left.
Linked list nodes with pointers. Insert fast, search slow.
Binary search, O of log n. Needs a sorted list.
Sorting, use Python sorted always. Never bubble sort in production.
Next episode, object-oriented programming in Python.
Subscribe so you do not miss it. See you tomorrow.
Data structures and algorithms unlocked.
Stacks, queues, binary search, Big O. You understand what most developers only memorize.
Next, episode 59, object-oriented programming.
Classes, objects, inheritance, all from zero. Subscribe. Leave your challenge reply.
I am Mahaz. See you in episode 59.